this here is just please and respect to me. Can you take one day where you're not on your phones or doing something? Just, I hope it makes it mean something to you. I hope I can give you a perspective on it. It'll take the whole hour, so get comfortable. You guys get some nice squishy, comfy chairs. What I'd like you guys to do is somewhere on that thing, you don't have to, it's just something to interact with. What I usually have you guys do while I'm getting like prepared here, write down some things that make you happy, and write down some things that make you sad. That's all it is. Buttered coffee, happy. Sushi, happy. Video games, happy. Racism, sad. Not turning in homework, sad. Students missing school, sad. Whatever it may be, get deep or is profound. Or you don't have to. I know, life's like, I don't want your hand to cramp. Be right. Hand cramps suck. Sad, right? Hand cramps. Alright. So while that's doing that, you gotta show me anybody find this funny. Other guys are gonna be hitting English. I found this in here in a while back.
Nope.
This is the extended version.
It kind of makes you want to break into song. Yep. I love the mountains. I love the clear blue skies. I love big bridges. I love when great whites fly. I love the whole world and all its sights and sounds. Boom-de-yada, 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 boom-de-yada.
I love the oceans.
I love real dirty things. I love to go fast.
I love Egyptian kings.
I love the whole world and all its meaning is. Boom-de-yada, boom-de-yada, boom-de-yada. I love tornadoes. I love arachnids. I love Alecna. I love the giant squids. It's such a brilliant place. Boom-de-yada, 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 boom-de-yada. I think it's
It's the extended version.
I cannot get that song out of my head. Totally. I'm going again. I love the mountains. I love the sun so bright. I love crustaceans.
I love the stars at night.
I love the whole world.
So many things to see.
Boom-de-yada, boom-de-yada.
I love the catfish.
I love the lemur eyes.
I love the future.
I love when humans fly. I love the whole world. The place I'd rather be. Boom-de-yada, 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 boom-de-yada. Still dirty. Still loving it. I love to blast off. I love adrenaline.
I love the Big Bang.
I love when I was them. I love the whole world.
And being part of it.
Boom-de-yada, boom-de-yada.
Alright. No laugh. Fine. Oh, crowd. Okay, so that whole video, guys, everything you do and you see in that whole thing is all, that's humanity, right? Every single one of those pictures is some way, shape, or form humankind. Okay? And a lot of the stuff that we teach you in astronomy, you know, will it relate to your everyday life? When I first took astronomy, I vividly remember the class. I skipped it like 3 days a week. It bored the crap out of me. I didn't understand what I was doing, what was the point of it, what was all this. And in reality, my whole journey through science, I kind of sometimes question that, right? The quintessential kid question, like, how am I gonna use this in real life, bro? I don't know. Probably not anyway. You know, you're not gonna like, no one's gonna like hold a gun to your head and be like, what's a neutron star? You know, at minimum, maybe you'll have a friend that'll say the sun will blow up and you're gonna be like, actually, you know, you're gonna show them up with science. But that's about it. That's totally wrong. It does so much more for you guys. And I'm kind of sharing with you here one of my keystones of my life, or one of the ways that I work and the way I think, and what science does for me in general. Because hope you guys see that I kind of like this here subject, right? Just kind of love the old science. It's an atom instead of a heart. No, it's okay. All right. So first, start with Carl Sagan's famous quote here. It's been said that astronomy is a humbling and character-building experience. If you don't know Carl Sagan, I'm sorry. You can't quite see it. This is a little comic. This is Calvin and Hobbes. I always started off with one of these here. Above it is a bunch of different stars with the lights right on it here. All right. So he's just screaming, "I'm significant," and then it says, "Screams the dust speck." This was the original comic. Genius. Absolutely a genius little comic, Calvin and Hobbes. So, you are significant though. In terms of size, scale, composition, you're starting to see it a little bit. Today I'll really drive the nail home. But that's the whole goal here, that in this infinite expanding cosmos, I want you to see that you're beyond significant, that you're epically significant. All right? So just reviewing a little bit here. I'm going to have to read this off the screen because it's a little hard for my color blindness. All right, so it says we open our eyes and we think we're seeing the whole world out there. But what becomes clear, and really in the last few centuries, is that we look at the electromagnetic spectrum, we are seeing less than 1/10 of a billion of the information that's riding on there. So we call that visible light. But everything else passing through our bodies is completely invisible to us. Even though we accept the reality that's presented to us, we're really only seeing a little window of what's actually happening. And you guys can see that, right? And that's incredible to comprehend. Your entire universe that exists in sound and visual and auditory senses is 1/10 of a billionth of the true information that makes up the entire existence of everything. And that's not even counting. That's like just the fundamental forces. Who knows what's in dark matter and dark energy? All right. So I've played this for you here. I'm going to play it one more time just because I think hopefully you can internalize this bad boy a little bit, and it's got some new animations. So once you get here, we'll fire it up. This is the astounding fact video again. Hopefully this means a lot more to you than the first time I showed it to you.
The most astounding fact is the knowledge that the atoms that comprise life on Earth, the atoms that make up the human body, are traceable to the crucibles that cooked light elements into heavy elements in their core under extreme temperatures and pressures. These stars, the high-mass ones among them, went unstable in their later years. They collapsed and then exploded, scattering their enriched guts across the galaxy. Guts made of carbon, nitrogen, oxygen, and all the fundamental ingredients of life itself. These ingredients become part of gas clouds that condense, collapse, form the next generation of solar systems, stars with orbiting planets. And those planets now have the ingredients for life itself. So that when I look up at the night sky, and I know that, yes, we are part of this universe, we are in this universe, but perhaps more important than both of those facts is that the universe is in us.
Should have a how can you not, in some way, shape, or form, if you're following the science behind this whole thing, just get blown away by that? And vividly, I can't explain to you. The images I'm going to show you today, that quote and all these things, there's times in my teaching career, maybe because I have ADHD and my brain stimulates a little too crazy. Like when I first saw this image, or these images I'm going to show you today, and I got it, I don't tell my bosses, but I couldn't teach. I couldn't handle it. It reminded me of that time I told you where back in genetics class at Western Illinois University, when I get this bomb of knowledge and oh my God, everything that I've learned since I was 5 in the woods with my dad is all connected. It's all connected, it's all spiraling together, it's all life, it's all here. So we start our little speech here with this, right? One of the most famous images that's ever been taken. Human beings traveled to the moon, this massive, epic, universal journey that these guys have taken, still probably the greatest achievement that we've ever done. And one of the things it does above all, and these astronauts will talk about it forever, like the knowledge that they got there and the objectives and the missions were all wonderful, but it was the perspective. It was the perspective that these guys changed, that changed in them, and that they changed for us. And just coming around the backside of the moon on Apollo 8, you have this tiny little guy chewing, remember, he was just chewing gum, had a long lens, he's just takes a picture, and this picture forever changes everything. And I went to Al Gore's Climate Reality Leadership Conference, and this was slide number 1. I was like, oh snap. Slide number 2 is pale blue dot, and I'm showing you. I was like, what? I'm valid. There we go. So I was excited. That's Al Gore, y'all. Anyways, so you get here, and what this shows you is it just shows its perspective, right? This is all about perspective. How is your world, how is your perspective changing? When you get to the moon, the Earth, this thing that we are on every day of our life, the good, the bad, the ugly, right here, it takes place on this tiny little blue dot that's just surrounded by infinite blackness. It just looks so fragile, you can't even see half of it. When the sun, there's no example of humankind on that bad boy, right? You don't see a single light, you don't see people giving you thumbs up, you can't make a cell phone call. There it is, that's it. That's where you are right now. If you were on this moon, it would pretty much still look the same way, sitting right here, right now at this given time. We're not on the moon though, because we don't fund NASA, but whatever, it's no big deal. All right, so that's where it all starts here. So to give us, remember, a little bit of perspective here, which I remote, be much more TED talky. All right, there's the Earth and the Moon, right? 1/49th the size of our planet. And you guys can see that even something as small as the Moon. I remember, like, in my little astronomy class in college, I apologize to that professor, whoever he was, he probably cared. You know, he was like, I remember he said the Moon was disappearing and we're going to lose it in a few billion years. It'll actually be slower than when we lose the Sun, but you know, whatever. And I remember thinking, like, okay, and then they actually played a chunk of that video that I showed you, and when I found out that the Moon controlled our axis of rotation, that was like one time in class, I was like, cool. You know, and I was like, back out, yeah, whatever. It was just so boring, and you just didn't make it exciting. That's the problem with science teachers. So science teachers of the world, can hold them to passionate, make them be passionate. Say, hey, let's go. I need you. All right? So our planet relative to the rest of them is tiny. Absolutely teeny, 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 tiny, right? We know this now. It's just a terrestrial planet. It's actually, though, in terms of complexity. Remember the complexity. It's much more complex than the big ones. Jupiter's huge. The star is huge. Whatever. They're lame. They're just made of hydrogen, helium, some methane, oh, whatever. Jupiter, no big deal. We're made of this. We're made of all of this. Everything you see here, these were atoms that were on this planet when the planet formed up, right? And we know these things. We know that this solar system, the thing that it took to create this bad boy, was a gas cloud 100 times greater than the sun is today. Remember that. Just think back to that concept here. 100 times greater. Voyager left in the 70s. It took 40 to 50, can't remember exactly, like 50 years for this thing, traveling at 32,000 miles per hour to get outside of just our heliosphere. Times that by 100, that's how much gas and dust it takes to form up that sun. 99.9% of that bad boy. The matter in our space, the matter in our solar system is found inside that sun. 1 million of these planets could fit in there, right? Think about how big this planet is. 1 million of them. Hopefully you get to go somewhere in college and after high school, or you've been already, that gives you a perspective on the Earth. You know, stand at a tall view and you're like, holy, you know, you just see the horizons and the layers upon layers of things. 1 million of them can fit inside that thing. 70% of that remaining 0.1% is found in Jupiter. It's leaving fractions of percentages left over for all the matter that can still make up this. Make up everything that we're seeing today. Relative to the rest of the stars, it's not that special. There's Earth to Jupiter, number 2. Then you got then there's Wolf. There's the Sun. The Sun's pretty much dwarfed by Sirius. Sirius can be dwarfed by Pollux and Arcturus. I can never pronounce these things. Aldebaran, right? You keep moving on down. There's Betelgeuse, Antares, but Antares is completely dwarfed by VV Cephei. When you look at the biggest known star in our solar system, called VY Canis Majoris, our sun is a pixel on the screen. Yeah, right? That's insane. That's insane, right? You've been up there and you've gone outside and you've seen these things. These are fractions. They're these little pinpoints of light, right? You know, think about all the stars you've ever seen. This star exists within our galaxy. 200 billion of these things can exist inside the Milky Way galaxy. Do you comprehend that bad boy? 200 billion stars. You see a point of light up there, that thing could be 100 times greater than the thing that 1 million of this planet can fit inside of. That's just our backyard. That's the Milky Way galaxy, okay? One galaxy of a lot of galaxies. You've heard this now. You've seen it. Hopefully it's stuck with you a little bit, all right? This information you got that was the image at the planetarium, was all these things, it all started with the Hubble telescope. It started with Edwin Hubble, right? It started with this grand journey of scientists. This, you know, I've stood on the shoulders of giants, human beings that have asked questions through millennia using the scientific method to get the culminating thing that is today. And today is the greatest day of knowledge that has ever existed in the history of mankind. And it starts with these. Every scientist adds a little bit to the soup that is just the soup of knowledge, the soup of trying to figure out what this stuff all is. So our galaxy alone is pretty gnarly, right? And now we know, we have an idea of what space is made up of. And we know that the vast majority of this stuff in this galaxy is just gas and dust. So this is a Hubble flyby they just released because Hubble turned 25 years old this year, flying through a 3D rendering of a gas cloud. And 4 ways to avoid money. What we did. You guys know this now. You know these things. You know what it's made up of. You know that the vast majority of it is just gas and dust. These tiny little points of light are all tiny little crucibles of fusion, but they're all made from these gorgeous, huge, massive nebulae. These stars these clouds that were formed from star death, from the death of stars that have gone on this incredible journey. Right? We start 13.4 billion years ago, and in seconds, the protons, neutrons, and electrons, the most most fundamental thing that makes up all matter in time and space, forms up, and it takes 100,000 years before it actually forms up into hydrogen and helium. Mix it with a little bit of gravity, and it condenses and compresses until these tiny little points of light are stars. Every little tiny little spot of glowing energy on this could be an entire solar system. Every one of them. There's so much stuff out here. This is just one nebula. You kind of get this idea when you fly through it. It gives you somewhat of a scale, right? It gives you this perspective as if this ship was there. But those points of light are not dust. They're stars. They're individual fusion-based stars that can just dwarf or be smaller, bigger, whatever. And there can be little rocks, little gas bodies floating around these bad boys, right? Our universe is made up of the same exact matter, and all of that matter came out of that point of infinite mass and density that we call the singularity. Totally, completely misunderstood. That's just another cool way of showing you, the power of Hubble and the power of scientific information. That's why I actually didn't name my dog after the telescope. I named my dog after the scientist because he was the first jock scientist. That's right. Big ups to Hubble. Good man. So they say you should dress around like big like flamboyant pimp coats and stuff. That's sweet. Would come to that. It was pretty cool because he actually never got a Nobel Prize. He was really mad about it. So here's our Milky Way galaxy. Again, it's not ours because our galaxy alone. If someone's like, it's a picture of our Milky Way galaxy. No, it's not. It's not. It would take you 28,000 years to fly to the edge of it. 28,000 years to fly back. If you can travel at 180,000 miles per second, can you? Can you? No, can't. It's probably not ever going to happen. That's the speed of light, people. 180,000 miles per second. 180,000. That's so crazy. And it would still take you 28,000 years to get to the edge, and then you'd be like, sweet, picture. Facebook. It would take you 28,000 years to get back to a Wi-Fi connection. Yeah. But I'm assuming if you could travel at the speed of light, I'm assuming Wi-Fi would be oh, remember Wi-Fi? You imagine, what if one day, what if we're talking about Wi-Fi like we talked about dial-up? Our computers make all this noise, and we're like, oh my God, the world of the internet is just blowing my mind. I can chat rooms. And now we're what happens? You lose Wi-Fi. That used to take 20 minutes to boot up. Now you guys get you don't have Wi-Fi. Oh, stupid school, spend some money on the guest network, huh? I can't look at YouTube and look at cats, So just think about it. What if one day that's just completely dwarfed? But this is a cool picture. You look up at the darkest sky that you guys can see, right? And every star that you're seeing, every single one that you see out there in space, in the nighttime sky, the deepest, darkest sky you can imagine is the Milky Way galaxy. None of those images, none of those stars are found inside other galaxies. You can see Andromeda on a really clear night. That's the only celestial body you can see that does not exist within the Milky Way galaxy. So think of the darkest, coolest night you've seen, that panoramic picture that I've shown you. See that little circle? That's where the stars that we see in our nighttime sky exist. So you think about how many stars you see in a nighttime sky, in the darkest, deepest, coolest sky you can see. It's only that circle of the entire thing that is the Milky Way galaxy. Right? It's just dwarfing. 200 plus billion, some say upwards of 1 trillion stars exist inside the Milky Way galaxy. So let's use that as our number, right? Inside one galaxy is 200 billion stars. That could range anywhere from 10,000 times greater than our sun to 1/4 the size of our sun. Each one equally made up, having the probability of planets being around it, all made up of the same stuff, the same stellar debris that came out of this amazing journey that has been the universe so far. And this is what this is, guys. And again, we're just telling you the story. This is scientists' story of how today became today. All right, so what this all comes down to, and what this really drives home this idea, and what changed my life forever, is what's called the Hubble Deep Field Image, all right? So the Hubble Deep Field Image was using Hubble in 1996. They looked at an area of the sky off of Canis Majoris. They did a comprehensive, taking pictures, just gathering light from the same fraction of space for upwards of 10 days, okay? So it's a total amount of 10 days of exposure of Hubble holding its camera right on a lens. And this happened in 1996, okay? It's known as the Deep Field Image. This was number one. So they get this image, and this is what they see. All right, so this is the image that comes out of this bad boy. You 10 days of looking at light, and you're like, okay. And I first saw this, and I remember seeing it in the back of that huge Cosmos book when I was trying to teach and just stay a couple of steps out of you guys. I was like, all right, cool, what is? In my mind, I thought they were stars. Those aren't stars. What are those? Yeah, whisper. Yes, they're galaxies. Every one of them is a galaxy. Every single solitary point of light on that image is a galaxy, okay? And what if I told you, like, that's the universe, right? And right there, guys, there's 3,000 galaxies in the known universe. You'd be like, oh, boom, no, oh my God. I'd be like, yeah, 3,000 times 200 billion stars. Like, stop it. I can't take anymore. I mean, right? That's pretty crazy. Well, why not up it? Let's do the ultra deep field image. Let's go back and revisit this same area of space in 2004, okay? Now they open up this image, they open up the light to for longer and longer periods of time, okay? You haven't even figured out quite yet where the area of sky that this came from, okay? There's a lot more than 3,000 galaxies in the known universe, okay? So they go up here. The area of sky is 1/10 the total area of a full moon. Not the sky, of a full moon, 1/10. That is the area of sky that you're looking at. You're getting near the eyeball of Abe Lincoln on the penny that you saw at the planetarium. Not quite there yet. So this sky, this image, comes from 1/13 of the entire area that is the sky itself. An area so small and void of anything. They pointed it at an area of the sky that to our naked eye looked black. Looked like nothing. We weren't pointing it at stuff that we could see. We just pointed at an area of the sky, and this is what they get. So this is what's called the ultra deep field image, okay? It's not quite, we still got the extreme ultra deep field image next. They've updated it as well. So just suck that in for a second. From the biggest to the smallest point of light on there, guys, is an entire galaxy. An entire galaxy exists on this. 5,500 galaxies exist within this image right here. Galaxies. If I told you stars, if I told you whatever, and if I told you that was the universe, again, you should be like, come on. 200 billion plus or minus stars exist within every single solitary point of light there. Every one of those housing 200 billion stars that could equally have planets forming around them, all made of the same stuff, the same matter, the same debris, the same stellar remnants that is. Come on. That is just insane. That's not fair. It makes you like, ooh, you don't feel good after seeing that, right? We're not even there yet. We're not even at the end. All right? So here's an example. Like using this image, this galaxy, I've never correlated this. I heard it talked about. I share it with you. Don't like take it to the bank or like go on a game show and tell somebody because I've not checked my facts. But supposedly this image here, this galaxy is too big to exist. Like it kind of defies our modern models of why and how a galaxy forms up, right? Because the more perspective we get, the more Hubble can give us and show us, the deeper, crazier our questions become. So supposedly this galaxy is too big to exist. What? It's crazy. But again, don't take it to the bank. All right, so the extreme deep field image here. Now what they do is they zoom in on the ultra deep field image. They take an area of the ultra deep field image, and they go deeper into it. They focus on it for an incredibly long period of time, okay? It's enough response of a correlation of data to take over 10 years of images from the same exact spot. So you get it, right? They got the ultra deep field image and they zoom in. They focus on one spot of that image that's up there. So now looking at this, you see galaxies in this next image that are 13.2 billion years old. 13.7 is the dawn of the existence of our Big Bang story. So these are images of almost at the beginning, right? 0.5 is so close to the dawn of time itself. And then, you know, the CBR gives us within seconds of that. I mean, it's just insane. We're close to figuring this stuff out. Maybe you are, maybe you aren't. So you're looking at this from the beginning, okay? So this is the extreme deep field image, zooming in right here. So again, it is just staggering, absolutely staggering. There are thousands and thousands of galaxies that exist within here. And again, if I told you that was the entire universe, your mind should collapse. But this image that you're taking in right now with all kinds of different looks on your faces, some are smiling, some are frowning, there's a lot going on. There's a lot, it's emotional, right? It's science. All from an area of empty space, from an area that we classified as empty. We look up there, to our naked eye, it looks like blackness, okay? So that entire image comes from an area of the sky this big. You with me yet? You took Abe Lincoln's head, you took a penny, and if I told you 5,500 galaxies exist behind a penny at arm's length, you'd be like, man, oh, sickness, thank you for changing my life forever. Did you hear him? It wasn't behind the penny, it was behind Abe Lincoln's eyeball at arm's length on a penny. It's like a pyramid. period, like a period at arm's length in the sky. Take that in, guys. Relative to the full moon, those thousands and thousands of galaxies are right there from that tiny square. So now picture the rest of the sky. So if Abe Lincoln's eyeball is 5,500 galaxies, I mean, come on. Does anyone know the number? What is the modern number of galaxies that exist within our universe? Nobody? 200 plus billion. 200 billion galaxies exist within the known universe. Oh! That's insane! 200 billion plus galaxies that have 200 billion plus or minus stars equal with the probability, let's say 8 planets around it? All made of the same stuff? All came out of this ever-expanding universe that we call the singularity? Oh, come on! Yeah, you thought you were small before. Yeah? Yeah, right? It's absolutely incredible. It's epic. Think about it. Exclamation points, right? It's the deepest we've ever looked. They're working on it. The James Webb Telescope may possibly be able to see galaxies that exist 13.6 billion years. And when they get out the Webb Telescope, they're going to point it at this spot first. And what it can do is they can take infrared. And what happens is when these galaxies are so far away and they're traveling for so long, the redshift takes place and their wavelengths get so long that they leave the visible spectrum and they go into the infrared. So we need a camera that can capture infrared images. And who knows what we're going to see. Come on, James Webb Telescope. Hope it gets funded. Because you guys know once Hubble breaks now, Hubble's gone. They're not going to fix Hubble anymore, which is kind of tragic. Very few things, if any, have changed the perspective of the universe and humankind more so, in my opinion, than the Hubble Space Telescope. And it was a direct correlation of NASA. Why do we need NASA? Because NASA allows us to get telescopes up there the size of a city bus to allow me to drop knowledge on you. You don't live in a universe of a sun and stars. You don't live in a universe of one galaxy. You live in a universe of 200 billion galaxies that is expanding, and it's expanding at an accelerating rate. So now think back to what you classified the singularity, right? That little image that we see on that thing. From that image expanded the matter that built a universe of 200 billion galaxies. Makes you look like emotional. It's insane. It built us. Come on. So just imagine the rest of it. Take it in, think about it, whatever it may be, right? So whatever this thing goes down, imagine what we're going to know later on. Imagine all of the wonder and awe of everything that exists. So this is just to give you an example here of these things highlighted. These are galaxies that date back, the oldest one up there, 11.9 billion years. That is an image at the beginning of this childhood that is the universe, right? And again, we talked about that like day 2. How would we get an understanding of something that's been here for 13.7 billion years? When relative to our planet alone, we're a human hair at the end of the football field. That's not even that's just an analogy to our planet, right? That's 4.5 billion years old. That's not an analogy to the universe that's 13.7 billion years old. That's like how long have we been doing science? We're getting fragments, snapshots of the past, getting farther and farther back to the beginning because we know the beginning of the universe, it's more understanding of the greatest question ever of, what is life? What is humans? What is all these things? That's at the core of science is what is blank? Why? Why is blank? Why does this happen? Science is just the questioning of everything. The universe we know and exist, and from this big to our phones and our world that we love, is all just because some person had the audacity of asking how, what, why, how can I make it better, what can I do, what is this, why did that happen, and voila, science, technology, and society merge. Take it in again. Insane. Thank you, big screen. You're so big. Wish this light wasn't directly on it, but whatever. It's not. Looks better on my screen, see? A little more HD. Okay, so you think, right? I could stop here and just like mic drop and walk away, and you'd be like, dang, Mr. Hofeld, you're welcome. Okay? So now I've told you we live in a universe of 200 billion stars. That's weak. That's nothing. That's one galaxy, y'all. 200 billion galaxies. All made up of the same stuff, right? That is matter. That was like, that's like the stuff that is out there, that exists. So you take all of that, how much matter would exist in 200 billion galaxies is insane. What is this showing us here? So if you take a pie chart of the stuff that makes up the whole sphere that you call the universe, or whatever that may be, the boundaries within it, only 4% of that is matter. Is gas, dust, stars, planets, atoms. 4%. 200 billion galaxies exist, with 200 billion plus or minus stars in each galaxy, and that's 0.4% of the 4% of the matter that is the universe. Come on. How has a pie chart ever affected your pie chart? Great. Think about that. 0.4% of 4% of that universe I just told you exists of 200 billion galaxies is what the stars are made up of, and you and me and the planets. The rest is just gas and dust? Oh, what? Not to mention 74% and 22% is dark matter and dark energy. You know what that is? You don't, because nobody does. You could call it frizzle-frazzle energy. It's just physics' way of saying, I don't know, it's dark. What do we call it? It's got to be it's got to act like energy. Do we know what it is? No, it's dark. Okay, dark energy, good talk. That's really what it is. We have no clue what it is because the universe is expanding. It's accelerating. The stuff isn't flying apart, right? Think about if I spin something fast enough, it's just gonna fly apart. The atomic stuff is gonna not hold it together anymore. But as the universe is expanding, accelerating the rate at which it's expanding, the stuff stays together. The galaxies, the debris, the things clump. They stay together, possibly held together through dark matter. Again, dark energy and dark matter, we map it and we theorize it based on the way gravity works, that gravitational lensing they talked about in the astronomy. So it's like we know it's there, but have we proven it? No, technically not. Some say we'll never be able to, right? But there were physicists way back in like the 1900s that said we've learned all about physics. It's not even worth studying it anymore. Just simply using Newtonian physics. Good work, buddy. He was a little off. And he's probably a guy who's exponentially smarter than me. But now we're going to get into humans here. So from this 0.4%, guys, it's 0.4 stars, etc. And etc. is us. That's the debris that's making up my shirt, my skin, my organs, my face, my brain, my voice. All right, so this was on Madison's blog. If every person on the planet watched and internalized this video just once a bit, I think the world would be a better place tomorrow. So what this is Carl Sagan's, an excerpt of his book called The Pale Blue Dot, all right? He took the satellite Voyager and took a picture of Earth that he was so moved by, he wrote an entire book about it, all right? And Carl Sagan is one of the greatest minds ever. I'm too bad he's not alive anymore. So just enjoy this. It's my favorite. Oh, yeah. Humanity, right? That's all we're doing here. Just perfect.
The gals stand out.
50 Shades of Grey on Blu-ray May 8th.
Don't let a guy treat you like that, girls. Just don't. Alright, here we go. Humans.
The spacecraft was a long way from home. I thought it might be a good idea, just after Saturn, to have them take one last glance homeward. From Saturn, the Earth would appear too small for Voyager to make out any detail. Our planet would be just a point of light, a lonely pixel, hardly distinguishable from the many other points of light Voyager would see, nearby planets, far-off suns. But precisely because of the obscurity of our world thus revealed, such a picture might be worth having. It had been well understood by the scientists and philosophers of classical antiquity that the Earth was a mere point in a vast, encompassing cosmos. But no one had ever seen it as such. Here was our first chance, and perhaps also our last, for decades to come. So here they are. A mosaic of squares laid down on top of the planets, and a background smattering of more distant stars. Because of the reflection of sunlight off the spacecraft, the Earth seems to be sitting in a beam of light, as if there were some special significance to this small world. But it's just an accident of geometry and optics. There is no sign of humans in this picture. Not our reworking of the Earth's surface, not our machines, not ourselves. From this vantage point, our obsession with nationalism is nowhere in evidence. we are too small. On the scale of worlds, humans are inconsequential. A thin film of life on an obscure and solitary lump of rock and metal. Consider again that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering. Thousands of confident religions, ideologies, and economic doctrines. Every hunter and forager, every hero and coward, every creator and destroyer of civilization. Every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every supreme leader, every superstar, every saint and sinner in the history of our species lived there on the mote of dust, suspended in a sunbeam. The earth is a very small stage in a vast cosmic arena. Think of the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner. How frequent their misunderstandings, how eager they are to kill one another, how fervent their hatreds. Think of the rivers of blood spilled by all those generals and emperors, so that in glory and triumph they can become the momentary masters of a fraction of a dot. Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe, are challenged by this point of pale light. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. Like it or not, for the moment, the earth is where we make our stand. It has been said that astronomy is a humbling and character-building experience. There is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. It underscores our responsibility to deal more kindly with one another and to preserve and cherish the only home we've ever known. The pale blue dot.
So I got for you there, I have the transcript of that written out in front of you right there. If you'd like to take a second and look at this and look at that. Again, you can't quite see the image here. But from Saturn, in the center of that circle, is what Earth looks like from 3 planets over. Alright? They've redone this, that's what the bottom one is down there. It was retaken by the Cassini spacecraft a couple of years ago. It's pretty insane. So, that's what this stuff's all about, guys, and people ask, why are you a teacher, why do you teach science? This is why. I don't truly care if you understand the process of nuclear fusion. I don't really care as much if you know what a true mitochondria does. It's pretty great. The cellular respiration allows you to breathe. It's all the energy everywhere. It all comes from the sun. I don't care about that. I care about the fact that for me, what this does for me, and hopefully transfers to you guys a little bit, is that the deeper, more profound impact and understanding you have of science, the more profound you should feel. You should feel as a person, and you should feel as a global thing that we call Homo sapiens on this little rock that we call Earth, forming around this one little soul that we call Sun. It's incredible. All right? That's what this all comes down to. It all comes down, that's a fly, I don't have time for that. It's pretty cool. So all this stuff comes in here, all right? what goes on in this world and what goes on in everything, you guys have an impact on. You can change, you can adapt. It's a choice on how you're going to interact with that thing as you exist here. All right? So like this says, Alan Watts is a philosopher, but this is kind of a cool little quote here. And if you read through it, at the end it says, you are the Big Bang. If this is the process that exists, this is just another step within the process that's continually expanding at an accelerating rate. Go all the way back now, this beautiful mosaic of the Big History Project with this, the ingredients and Goldilocks conditions and new complexity, organizing all the way into this very second right now. All right? This second, as you guys are about to graduate high school or go on to your senior year and see what's up. All right? So all of these things exist, guys, and the reason we're going to do this, and the reason why this is so important, and the reason why everything we're knowing and learning and loving about is because of these ideas of why you should feel special. I told you at the beginning of the year that I don't want this to make you feel insignificant. I want this to make you feel more than significant. Because in my mind, the bigger the universe gets, the more special you are. If I told you the universe was this big and the atoms that comprise you, me, and us and humanity formed up and found each other, I'd be like, okay, cool. It's not that, it's inconceivable big. It's a universe, 13.7 billion years old, composed of 200 billion galaxies, each galaxy having 200 billion plus or minus stars, each star equally having around the probability of planets orbiting around it. Everything from those galaxies to those stars to those planets to the surface to the things that make them up is all comprised of the same matter, following the same chemistry, following the same physics. All of it. Any way, shape, or form, you look at that, it's pretty incredible. So we go back to this thing here in the closing 5 minutes here. This is why you got to deal kindly with humanity. This is why you got to care about this, because every existence, every moment of your life, my life, our lives, generations of lives to come, generations before us, have all taken place one place. It's all taken place right there on a thing that we call Earth. Inside a universe that is composed of 200 billion galaxies alone that we even know about. It could be more, it could be like, it's insane. All of these things are here, right? The greatest things you can imagine in your life are going to take place there. The worst things you can imagine in your life are going to take place. The greatest things of humanity exist right there. Love, kindness, helping someone across the street, picking up someone's book, your favorite meal, your favorite song, your boyfriends, your girlfriends, falling in love. It all exists right there. It's all there. Along with war, hatred, homophobia, racism, bullying, falling out of love, heartache, whatever it may be. It's all right there. That is why it's so vital that you care about yourself. And it's so vital that you care about humankind and this planet. There's no other place to go. As human beings exist right now, this is where we make our stand. On this tiny little planet, composed of all this matter and energy, each of us being the same thing. This little organism that is fueled by sunlight with tiny little plants. You go outside now and you understand that that grass, that tree, that bacteria, that plankton, whatever it may be, it is taking in toxic stuff and spewing out oxygen for you. It's giving you air to breathe that you can mix with sugars that have come from the sun. We're fueled by stellar sun energy. That's just insane. So when you think about that, why you don't feel special blows my mind. Guys, you exist. The probability of you being you is staggering. If you take into account the idea of half your chromosomes from mom, half your chromosomes from dad coming together, it's an insane amount. If you take into crossing over, you are one out of 100 trillion possible genetic combinations that exist. Your parents could mate 100 trillion times over and there would not be another you, me, us, ever. It's not how it works in terms of genetics. How does that not make you feel special? And then backpedal backwards in a probability of a human's race of 6 billion people, your parents finding each other and falling in love, and their parents' parents finding each other and falling in love, and their parents' parents' parents falling in love, to get to the correlation of the probability that you get to sit in this chair as a human. So when someone comes up to you and they're like, hey, how you feeling? Don't go, Be like, well, let me tell you, right? You get this little blurb, you get this little tiny existence on this little thing that you get to choose how you interact with it. You can embrace knowledge, you can embrace thought, feelings, emotions, you can embrace kindness, you can embrace love, you can embrace all these things. You can wake up every day and make the world a better place. Because now you see how epically wonderful the universe is. In a universe of 200 billion galaxies, we've yet to find microbial life. That's just, who knows, right? That's a whole different conversation. Is there life out there? There's a lot of stuff. There's a lot of stages for life to exist. But let's just say this is the only one. Why would you not cherish it? Why would you not think, feel, and try and love with all the power that you have, knowing that you are a tiny little coagulated ball of chemical energy that exists on tiny one little rock orbiting around one star, formed up in a galaxy of 200 billion stars, in a universe of 200 billion galaxies that 13.7 billion years ago expanded out of a single point? I mean, how does that not just make you feel insane, okay? So that's hopefully what this does for you guys. So as you go forth into your world here, whatever you choose to do, choose it and do it with fire. Do it with as much passion and enthusiasm as you can muster. There's gonna be good days, there's gonna be bad, right? Be kind, for all are fighting a great internal battle. It's a Buddhist quote or something. It's a great little quote there when you think about it, right? I quoted that really well. Some guys heard it. You know, that's what this is all about, guys. And this is hopefully what I do for you, what I can do for you here, and what this class can do for you, me, and us, is that it can make us think about this. That you can walk around and integrate with the world and interact with it and think and feel and love and just be kind to people, guys. I mean, you think of the world, there's so much that could be benefited if we're just kinder, if we're just a little more gratitude. If you wake up every day and take in a deep breath and just maybe think about the oxygen that's going in, this precious little organism. The air that's breathing, we share. It's been here for all of humankind. Your grandma could have breathed in this air. The carbon that you get from your food could have been intaken by a dinosaur. The water in your water bottle has been here for 3.5 billion years, and you see it. Not only do you see like the journey that is Earth that formed up the environment of today, you now see the entire progression of the universe that went back. And if you follow the science, it's a sequential order of events that if they would have diverted or changed or not taken place in that precise way, the moon would have missed us, it would have hit us dead on, the asteroid would have missed, you know, like what if Jupiter would have gotten a little more matter and ignited a secondary star? We wouldn't exist between two binary star systems. You know, the bigger this stuff gets, the bigger and deeper astronomy gets you, the more special you should get. Because I'm here to tell you guys, you're beyond special. You're an infinite universe of yourself. You're made up of 37 trillion cells. 37 trillion cells, and just like the Big Bang, you started as a singularity. You started as one individual cell smaller than the head of a pin, and it organized and replicated and divided into the organs and the systems that make up you, that allow you to interact with the world and oscillate your vocal cords and create music. Draw colors on a screen and have you perceive the concept of beauty. Create color and art and wonder and laughter and all these amazing things you can do because of the system that is you. So think about that as you go. Use the idea of the singularity. What are you going to put into play today that is going to infinitely expand into nothingness? The universe went and just expanded into nothingness, and in its wake was the universe. What goals, what ideas, what emotions, what thoughts, what feelings can you hold on to today to see what could take place that could possibly forever change the world? That's what this stuff's all about, guys. We got to interact with this world. We got to take care of it. You got to belong, and you got to behave to everyone else because there's nowhere else to go. If you don't fit here, if you can't integrate with humankind, where are you going to go? There's no other place to be, right? So go out as you never see me again. If you ever want to rap about this or whatever, hopefully you just come back to this. When you're having a good day, try and sit down and be like, all right, I'm made up of 37 trillion cells, whatever, whole fell. Inside a universe that is galaxy made up of 200 billion stars. That's pretty cool. Inside a galaxy there's 200 billion galaxies. All right? And you just keep on going and keep rolling through it. That's what it's about, guys. That's what science does for me and you and us. All right, go forth, people. Enjoy life. Be happy.